So what we are going to discuss regarding is radioactivity. Okay. Now you know radioactive elements, right? Uranium, plutonium, thorium, and there are so many radioactive elements. The thing is, those elements existed in earlier days also. Nowadays also, this element is being existed. The thing is, they are unstable mostly. These radioactive elements like uranium, plutonium, thorium. So everything in our Earth, it likes to be stable. So what they do is, in order to become stable, they emit like alpha particles, beta particles, and the parent nucleus, it changes another thing, another atom. It is like it is going to move towards some stable state. So what I am telling here is, now in order to explain this radioactivity, I am going to take a simple equation. Let's see, this is radium. Okay, atomic number 88, mass number 226. So what does it is doing is, it is emitting an alpha particle. Alpha means, you know, atomic number 4, mass atomic number 2, mass number 4, and it is changing into another atom, radon 86, 220 plus energy. The another thing is, we should know to balance this equation also. First of all, I am writing an equation. From this equation, I am going to explain. The thing is, now radium, it is unstable. Okay. So what does it is doing is, it is emitting an alpha particle. Okay, it is removing. Now this is the radium atom. Okay. So it is removing an alpha particle. That means radium is removing an alpha particle, minus alpha. Normally it is not right to write, not nice to write minus for that. Why alpha is going this side. So one of the alpha particle, it is being emitted. If an alpha goes out, okay, one alpha particle goes out, you see alpha atomic, that means proton number is 2. Okay, it has 2 protons. 4 is the number of protons plus number of neutrons. Okay, so when an alpha particle goes out from a radium nuclei, unstable nuclei, it is emitting alpha particle. What happens means, its proton number decreases by 2. That means initially it is 88. Okay, radium element, it has 88 protons. Now one alpha released, no, therefore 2 protons get deducted. Now 86 protons. Okay, now its mass number is 226. Mass number we can say, nucleon number we can say. That means 226 is the number of protons plus the number of neutrons of the radium atom. And if one alpha particle goes out, the number of protons plus neutrons decreases by 4. That's why 226 minus 4, 222. Okay, later we will discuss how to balance the radioactive equations. Now the thing is, why I am telling you why this radioactivity thing is happening. So definitely they have told in the note also, when an unstable nucleus disintegrates to acquire more stable state, radiations are emitted. Now this radioactivity, there are 2 types of radioactivities. One is spontaneous, other one is non-spontaneous. Spontaneous means it is occurring naturally. Now radium atom, naturally, it takes a lot of years. Like not like a chemical reaction. If you consider chemical reaction, A plus B gives C, or magnesium plus oxygen, we are reacting in the laboratory and producing magnesium oxide. These are like these we call chemical reaction. Both are different. This is radioactive reactions. That is different than chemical reaction. Now this chemical reaction, magnesium plus oxygen forming magnesium oxide, it's like in the lab we can carry out within 10 minutes or 5 minutes, we can. But this happens years and years. It takes a lot of time. Radioactive reaction. But when you consider chemical reaction, okay, when you consider chemical reaction, normally in chemistry, we discuss like mass is conserved. The thing is, here in radioactive reaction, we try to think for energy. What happens is, now normally in physics, all the other lessons, we didn't get a concept as mass is like energy. Now here we will discuss another equation. E is equal to mc square. So during radioactivity, what happens is, now you see, now there is an atom. Okay, any atom, radium atom. Since it emitted an alpha particle, it is changed as radon. Then there will be a mass loss, isn't it? Radium mass is different. By radium, its nucleus, okay, it has 226 spins. That means it has 88 protons, 226 minus 8. This much of protons plus neutrons in its nucleus. You know, protons, subatomic particles, protons, neutrons, electrons, significant the mass is determined by protons and neutrons. That only significant mass. Now here, it is coming red and no. Now the proton number is different. Here 88, here 86. Proton number is different means what happens is some amount of mass has been lost. When radium is changing to radon, there is a mass loss. So if there is a mass loss, that will be generated as energy. That's what we are producing. A significant amount of energy is produced in the radioactive reaction. In the syllabus, they asked to balance this radioactive reaction. The thing is, it is different from the normal chemical reactions. In normal chemical reaction, there is only a negligible mass loss. We are not considering. But in a radioactive reaction, there is a huge mass loss because one element is changing as another one when it is emitting an alpha particle. Okay, see now we call this radium as parent nucleus. Okay, parent nucleus. After emitting an alpha particle, radon forms, right? This radon we call as daughter nucleus. Okay, daughter. Okay, then after that also it can continue. The reaction can continue. Now radium, it looks like some 3 or 4 years, and it is like small amount. We will study a decay law after this. Okay, then you will understand it clear. It takes a lot of time. It is decaying, and it is empty alpha. It is changing as radon. Then after that, if the radon is a radioactive element, again this radon also can emit some other particle and changes another element. Okay, the thing now you have to remember is when alpha particle comes out. Okay, definitely it is changing this element. Similar to alpha particle. Another particle which can come out from the parent's nucleus is beta. Beta we call -1, 0. Okay, so we have alpha, beta, gamma. Okay, these are the 3 in the syllabus. So what happening is these unstable nucleus, radium, any element. This is I took an example. Thorium, plutonium, uranium, any element, which are unstable in the nature. Okay, these reactions are occurring spontaneously. That also keep in mind. Now, atomic bombs and everything, nuclear fission and those reaction, fusion, those reaction, what we do is for an element, we like pose a neutron to its atom and we do those reactions. If we pause and do those reactions, it comes under non-spontaneous radioactive reactions. Now, this case, it comes under spontaneous radioactive reaction because it is occurring naturally. So many radioactive reactions, so many reactions. Since it is occurring naturally only, it's taking a lot of time. That means we are not providing external physical condition and all. Now in chemistry, now you know if a reaction, if it occurs really slow, what we do? We put catalyst, we change the external pressure conditions and everything, and we fast up the reaction. But a radioactive reaction, we can't do like that. That means using a catalyst and everything, we can't speed up like that. That means it doesn't depend on the physical conditions. That is also an important one. Okay, sometimes they may ask you write the difference between a chemical reaction and radioactive reactions. Then you must be able to compare. Okay, so did you get it what I'm telling right now?
Yes.
Hello. Okay. Okay. Then before one thing is we have to learn to balance these radioactive reactions. So before that, okay, so just I read the note. Just get into my now revision, right? So what is the main thing in the radioactivity we should get it is when an unstable nucleus, okay, this is the unstable nucleus, radium, disintegrates to acquire more stable state. Okay, it is disintegrating to acquire more stable place, convert as radon. What they are telling is radiations are emitted. The disintegration is spontaneous and most commonly involves the emission of an alpha particle or a beta particle. Now, this particular reaction, I told alpha. Some other elements it can emit but beta particle. Definitely, if it emits beta particle, also it will change. No? Let's say the same reaction, let's consider some other element. Say, let's say some A element A. Okay, it has an 29, and here let's say but 126. It is emitting a beta particle. A some element. I don't know. Definitely a new element C will form. Okay. So definitely, when it is an emitting an alpha or a beta particle, definitely this radar means radio. New element is being formed. That is the new thing in this radioactivity. See, in both alpha emission and beta emission, the parent nucleus undergoes a change of atomic number. Okay, that is also another key point. Here, by balancing equations also, that will be really helpful. And you see, and this is an unstable nucleus. Okay, so when it is emitting an alpha particle, a new element is being formed. No? So the reason is when alpha goes out, two proton number decreasing. Now, using proton number only we tell. Now, you know sodium in the periodic table. How do you differentiate sodium and magnesium in the periodic table? Atomic number we have assigned. So definitely if alpha goes up, this is 2 proton number decreasing by 2 means definitely new one will form. Similarly, beta also goes. When beta goes, what happens? Minus 1. See, not bad. This is 29, this is 28. Minus 1 means this is 28. So that what happens means it is changing the proton number. That's why a new element is being formed. Okay, when alpha goes out, what happens is proton number decreases by 2. Similarly, when beta goes out, what happens is proton number, when beta goes out, what is happening is, now see, okay, now for example, let's say they ask you to balance the equation, okay? First, let's do that. Okay, how do you balance this equation means, okay, generally you write and keep, then any question you can do. Let's say X is an element, okay? And here I specifically took randomly X is an element. Its atomic number is Z, mass number is A, okay? Atomic number is Z, mass number is A. Now, they are asking you to write, now the question is X is emitting an alpha particle. Okay, X is emitting an alpha particle and it forms Y. Okay, and it forms Y. So they are asking you to fill this. What is the atomic number here and what is the mass number here? The thing is, now what is happening is X is emitting an alpha particle. Now X is emitting an alpha particle means what happens? Now this is the nucleus. This is the X. In X there are protons and neutrons, everything are there. Now it is one alpha particle is going out from the nucleus. One alpha particle is going out. Then alpha means what? 2, 4. So when an alpha particle goes out, proton number it decreases by 2. When alpha goes out, it takes 2 protons and go. That means initially it has Z number of protons. Now proton number decreased by 2 now. Therefore, here Z minus 2. When an alpha goes. The thing is why I am writing alpha here is normally what happens is this element X, okay? This element X, it is removing an alpha but it is not nice to write minus V here now. That's why we are taking that minus and writing in the other side. Okay, so that what is the meaning is this is the X element. So it is emitting an alpha particle. So its proton number is 2. This is protons plus neutrons. Then Y element is being formed. So when an alpha particle goes out, proton number decreases by 2. That's why the new element formed is initial one Z means this is Z minus 2. Then what is its mass number is, yes, see this is A. Okay, when an alpha particle goes out, 2 plus 2. 2 protons plus 2 neutrons goes up. This 4 is what? That is mass number. It has protons plus neutrons. Totally 4 particles go up. So initially A is there. Then the new element mass number is A minus 4. Are you clear with writing this A minus 4 and Z minus 2?
Yes, sir.
Yes. Okay. So are you okay with balancing radioactive reactions? If I give like alpha, beta and everything, elements, can you balance?
Yeah, can balance.
Yeah. Okay, then I'm not spending in the, time in that. I'll go to the next one. Okay. Then we study the difference. So that is the main thing. Then next, I think there is difference between alpha, beta and gamma. That is one thing is there. And decay law. Okay. So alpha, beta, gamma, there is difference. I think that was in the theory. So just I recap. Okay. Alpha, beta, gamma. Difference. So first property what we are going to discuss is charge. Okay. So this charge is, now this is 2, 4, you must write this, beta minus 1, 0, gamma 0, 0. Gamma ray, charge is also 0, mass is also 0. Neutral thing. That means so in some past papers they ask like in an electric field or a magnetic field, if you say gamma ray, it won't be reflected because it is neutral. Okay, but beta, you can imagine beta is similar to electrons. Okay? Similar to electrons, you can imagine beta because it shows properties like that. Alpha also similar to like a positive charge like that. You can imagine when they ask like questions, sometimes they mix with in an electric field or magnetic field, the deflection and everything, you can imagine. The thing is now the mass, speed, those things you must know. If they ask charge, alpha's charge is 2 Faraday, beta is minus 1 Faraday, here charge is 0. Properties sometimes they can ask. If they ask speed, alpha travels with 1 over 10 of the speed of light in air. Then beta, half of it, and gamma nearly it is traveling with the speed of light in air. Then another thing you must know is penetration power and ionization power. So alpha, beta, or gamma, out of these three, which has the highest ionizing power? Okay, and which one has the highest penetrating power? Okay. Sometimes they ask like that. So now according to alpha, beta, and gamma means according to mass, gamma is light. See mass 0. Beta is near to electron. I say beta, you can assume like electrons. So electron, mass is really small, like 1,840. So alpha has a significant mass. So which one has higher mass? It has a good ionizing power. Okay, then ionizing power is really high for alpha. 10 to the power 5, 10 to the power 2, 1. Sometimes they ask like order of the ionizing power. Then they give answers like alpha, greater than beta, greater than gamma, like that. Okay, penetrating power. Penetrating means it should go through a medium. No, if its mass is less, it can easily go through. Therefore, gamma has the highest penetrating power. Other way around. No need to know these exact values, but better to know which one has the highest ionizing power out of alpha, beta, and gamma, and which one has the highest penetrating power out of alpha, beta, and gamma. And in order to write as inequality also. Okay. So that is the main thing. And again, I told you the difference between radioactive reactions and chemical reactions. Okay. Now the thing is, this alpha, beta, and alpha, beta coming from the nucleus. Inside the nucleus only it is coming. Now, when a nucleus is unstable, in order to become stable only, what it is doing? It is emitting alpha and beta particles. Then it is becoming stable. Okay. So it is coming from the nucleus. But in a chemical reaction, the valence shell electrons are only involved. This is happening inside the nucleus. Balancing chemical equation means this is not directly related with chemical. This is a little bit different, these radioactive reactions. Now, normally in a chemical reaction, we say like in chemistry, like mass is conserved. Conservation of mass like that in a chemical reaction. But here no. If any radioactive reaction if you take, there will be a mass loss. By radioactive reaction, what is happening? Alpha is coming out, beta is coming out. If alpha is coming out, 2 protons are coming out. There will be significant change in the mass. A new element is being produced. Similarly, if beta is coming out also, there will be a change. When beta comes out, it changes a neutron as a proton. Anyway, if the total number doesn't change, but generally, one of the neutron is converting to proton, or proton number is increased. Therefore, definitely there will be a mass loss in a radioactive reaction. Any radioactive reaction if you take, spontaneous or non-spontaneous. But in a chemical reaction that we discuss in chemistry, no mass loss like that. Okay, but in a radioactive reaction, if you say a new element is being formed, right? If alpha particle is coming out or a beta particle is coming out, now we took at the reaction radium. Radium emitted an alpha particle and radon is being formed. Okay, a new element is being formed. So you must know like 1 or 2 differences between chemical reactions and radioactive reactions if they are asked right. Okay. So next, what we are going to discuss is, we discussed about alpha particles, beta particles, gamma particles, and difference in alpha, beta, gamma, and the differences between radioactive reactions and chemical reactions. Next, we are going to discuss decay law. Up to what I told, are you okay? Any doubts with alpha, beta, gammas? Hello? Can you hear me?
Yes.
Okay. Now, why there is a law called decay law is, now I told earlier, now, these elements, but uranium, plutonium, radon, these reaction, it doesn't occur like within a while like that. It takes so many years. Okay. So what are the common radioactive elements are the uranium, okay, thorium, polonium, radium, radon. These are some of the radioactive elements. Okay, in periodic table also you can see like when we are writing periodic table, we don't consider these radioactive elements that much because they change. Each and every time uranium is emitting alpha and converting to another element. Mass and everything changes like that. So those elements mostly like in periodic table largely we include, but we don't discuss that much in chemistry. Okay. Then the thing is, these elements are emitting alpha particle, beta particle, true, and it is converting to another element. But this doesn't happen like in 1 hour or 15 minutes, like short time. It takes like millions and millions of years for this to happen spontaneously. Then, when we are talking regarding this, we are talk a law, decay law. So, that means this much of time it took to decay. That means in a unit time, how much amount has been decayed. So, physics mostly everything what we are talking for a unit time. So that in order to talk that, there is a law called decay law. Okay. So we are going to do some calculations. So earlier now we talked theory, alpha, beta, gamma, this balancing and equations and everything. So how using this law, what we are going to do is we are going to calculate in this much of time how much is decay. So and after talking with decay law, we are going to move for half-life period and all. Okay. So first of all, let's say decay law. So what the decay law it is telling is dN by dt is directly proportional to it. Okay. So what they are telling dN by dt is directly proportional to it. The rate of decay is directly proportional to the number of parent nuclei present. dN by dt we call as the rate of decay. Okay. dN by dt we call as the rate of decay. So rate of decay is directly proportional to number of nuclei present there. That means now this rate of decay is differ from element to element. Uranium, thorium, polonium, radium, radon. Some of the radioactive elements. And uranium and thorium inside the nucleus is a proton plus neutron number same? No. Uranium is different, thorium different. Both are different. So this decay law saying this rate of decay is directly proportional to its number. Okay, so that's what the law says. It says this we call as the decay law. The rate of decay is directly proportional to the rate of the parent nuclei present. Now, in order to change the proportionality sign into an equation, we should introduce what? A constant. Therefore, we can say dN by dt is equivalent to lambda into A. Okay. This lambda we call as decay constant. And we used to put a minus sign like this. Okay. The thing is, we derive this equation. Okay, so some most of the physics equations like they derive using integration and differentiation and those stuffs, but no need the derivation. The equation is enough. Okay, so dN by dt is equal to minus lambda into A. This lambda we call as the decay constant. What does this minus sign implies? Means it is decreasing. With time it is decreasing. Now we can depict this in a chart also. So what is happening? Really, what is happening is now initially inside now this is the reaction. Now what is the reaction we studied is radium is converting into radon. See, the reaction we studied, radium 88, 226. It is emitting an alpha particle and it is converting into radon. 86, 222 plus energy is being released. Now, this radium is converted into radon. Okay, that means this radium should decay. With time, it will decay and only it can convert to radon. So, if I draw a diagram with time, the number of the present inside radon, that means proton plus neutron number, what happens is with time it decreases. It decreases, it decrease. It takes like infinite time. I told like no, these reactions they happen like millions of years. Because this reaction I am not doing. These are naturally spontaneously happening reactions. Okay, in radioactivity, some reactions I can do that atomic form and everything, fission and fusion. I can do those reactions. I can set a nucleus heating and everything target and non-spontaneously I can carry out quickly. Now I'm not talking about that. I'm talking about the spontaneous reactions that are happening. Those reactions like this spontaneously naturally happening, you know. So those conditions and it takes a lot of time. That's why it is going. It's approaching infinity. We can't millions or after millions of time, it will completely fully decay and finish. Okay, this is the graph for with time, the radon number of molecules, how it is decreased. That's why we are talking this law. dN by dt is lambda. Okay, but in a unit time, how much it is being decayed. That's why we are going to introduce a decay concerns. Decay concern is like now every element, like not equal. Like, let's say uranium, it takes like a million of years to decay. But thorium won't be like that. It will take like thousands of years. So different elements, its property is different. Therefore, decay constant that is specific for one element. Uranium, it will have a decay constant. Thorium, it will have a decay constant. Different elements behave differently, right? Okay. Then, if I do a graph for radon, so radon, what happens is initially no radon. Initially we have Rn. Then with time, radon will increase. Number of molecules with time, radon will increase. After that, it will be test. That also will take a lot of time. So now you know why radium gave radon, because radium is a radioactive element, isn't it? Radium is a radioactive element, therefore it is unstable. Therefore, in order to become stable, what it is doing is it is emitting this alpha or some beta radiation and it is converting into radon. Okay, if radon we call as a daughter nucleus, right? Radium we call as what? Parent nucleus. If radon is also a radioactive element, okay, what radon also will emit some thing and it will convert to some other element. Okay, that reaction also will take millions and billions of years. That's why before millions and billions of years they talk about radioactivity. Still we are talking. Still it is happening because of this reason only. The formed daughter nucleus also may be radioactive. If it is not radioactive, the reaction will stop there. If the formed daughter nucleus is also radioactive, what happens? Again, it will also start to decay. Again, another reaction will happen. Radon, it will emit some alpha and beta or something, and it will become converted to another element. That is continuously chain and chain is happening. Now also it is happening. Now, if you decide like element has something underground, and if you see calculate how many years it is there, you will tell radon is forming. Like it's billions of millions of years, its reactions happening, and because of this instability. So everything it had to become stable. Okay, now if sometimes if the form radon is a stable one, then it will stop at that position. After that, it won't try to decay. It depends on the formed one. Did you get that?
Yes, miss.
So this is the basic equation. dN by dt is equal to minus lambda and m this. Okay. So next thing we are going to talk is okay. There is an equation called. Do we know this equation? N is equal to n naught into e to the power minus lambda d. Do you know this equation already?
Oh, yes, miss.
So I'm okay. Then it's easy. Now the thing is, now we talked about this decay and everything. Now, these equations, they will ask some sums, and another important topic we should know here is half-life time. Okay. Now, what is half-life time means? Now, initially, there are 100 molecules. Let's say, simply if I say there are 100 molecules, that 100 number, in order to become 50, how much time it takes? That time we call as half-life, simply. Okay? So the thing is, now for these radioactive elements also, we are going to talk a thing called half-life period. Because these reactions, it is occurring million and billions of years, like the half-life period also, like a significant value, it will come. Okay. Now, the thing is, in our syllabus, we should derive an expression for half-life period, and using that, there are some calculations also, and there's a graph also. Okay. So now let's say how to derive the expression for half-life period. If you know the expression, but we need to know. If it is an integration, differentiation, derivation, they won't ask it directly. Okay. Now half-life is thing is I told the initial number in order to become half the value. That is half-life. Now you know this equation. N is equal to n naught into e to the power minus lambda t. What is this? N naught is the initial number. Initially, how much it is present. Now this n is, now we put a time here, no? Minus lambda t after a particular time, after 4 days, after 8 days. What is the number is there? Now it will decay, no? Now what is this equation is telling? Now let's say a radium atom. Now it has protons and neutrons and everything. Now what happens with time? It is decay. Okay, that's what I told the graph. Now with time, it is a small time also, a particular amount will decay. And it is being less and less and less. Now, in this equation, what we are going to calculate is, now n is equal to n naught into e to the power minus lambda t. Now we put the time like that, now 4 minutes or 4 years. After that, at that particular time, how much number is remaining? Okay. So immediately now you put down the reaction, we write this uranium atom, it is emitting an alpha particle and changing like this. That what happened immediately? Very small. So minutely it is happening and happening. It is moving. Then only it is coming up. It is taking a lot of time. So that thing only we are going to investigate using this equation. N is equal to n naught e to the power minus lambda t. Now this n naught we call as the initial number. And initially, what I discussed, radium or radon is initially how much number is there. I will put it here. Okay. E to the power minus lambda. Lambda we call as a decay constant. That is different elements. Uranium 1 value, thorium 1 value, polonium 1 value, radium 1 value, radon 1 value. This time is how much time takes. After a particular time, I can calculate how much it is present. Now this uranium, it is decaying. Let's say it takes like 20 years to decay completely. Now I can put 4 years. After 4 years, how much uranium amount is now there?